Welcome to GateX AIML. So today we'll start the concept of calculus and optimization. So before we into that, there is some simple concept called as concept of functions. So you may have already learned them in your basic level like high school, PU, pre-university level. Okay. Now these are obvious concepts, but only thing is you need not remember the things here, but you have to understand what is a function or the different types of function, because the exam when they ask in the competitive exams when they ask, so you must be in a position to think, okay, what is this type of function and what is the expected outcome. Then only you will be able to solve problems. Okay, so let's begin. So what is a function? So let us understand it like this. So say there are two sets. There are two sets. Set means you understand, right? Set is nothing but a collection of objects or items. Let us say there is a set A and then there is a set B. Okay. Now, let us represent the set by this oval diagram for simply understanding the function concept. So set A and set B. So set A contains 1, 2, 3, 4. Set B contains a 10, 20, 30, 40. Take one more, 50. Okay. Now, first we'll define a relation. Relation between two sets means what? Suppose that we have a mapping like this. So I write set A, element of A, capital R related to a small b, element of set B. Okay, this is called a relation. Relation means we'll write in the ordered pairs. For example, I have a map like this. What are the ordered pair here? A related to B. So 1, 20. And this is set A element, this is set B element. They are the relation. Then we have 2, 10, 3, 30, 4, 40. Okay. So this is the relation between the set A and set B. Now what is a function? A function is nothing but a relation where each input maps to exactly one output. That is the first. What is a relation? A relation is a set of ordered pairs x, y linking elements from set A to set B. That is what you are linked. So a function is a relation which relates to sets. Okay, and what is the condition? A relation where each input maps to exactly one output. See, 1 is mapped to 20. If I map 1 to 30 and 1 to 20 also, then it doesn't fit as a function. You cannot call it as a function. Okay. What is the definition of function? A function, a set of inputs. You can imagine like this. The set of inputs you give and you define a function. Okay, some black box. And then it gives you the output. So x you give to a function f and then it will give you the output f of x. That is a definition of function. So function is a relation where each input maps to exactly one output in the other set. So set A, one element maps to exactly one element in set B. And the first one is that condition. So maps exactly to one element. Second thing is the function defines a rule. See, rule means what? Mapping. So 1 has to be mapped to 20. That is the rule. Some rule I will give. So that it also defines a rule. It maps exactly one element. Which element to map is defined by a rule. So that is exactly the definition of function. So function is a relation. A relation is nothing but a ordered pairs relating the elements of two sets. And a function is a relation where each input has maps to exactly one output and the function defines a rule for this mapping. Now, in this The set A is called as domain. The set B is called as codomain. For a function where it maps is codomain. From where it is mapping, it is mapping from A, set A, that is called as domain. Domain contains all these elements. Domain is set of all the elements here. What is codomain? Codomains contain set of all the elements on which it is mapped. So 10, 20, 30, 40 and 50 is the codomain. Now there is a concept of range. Now range is nothing but the subset of codomain. Subset of codomain. Subset means we take only few elements from the set B here. Okay. So that means what is the mapping done here? See, which all elements are mapped in set B are the part of range. Okay. So 10 is mapped, 20 is mapped, 30 is mapped, 40 is mapped, 50 is not mapped, right? So that is the range. Range is, now if you see, this is the subset. Okay, this is the subset. This is the subset of codomain. So range means whichever elements are mapped in set B. Okay, the one is mapped to 20, 10, 30, 40 are all mapped by one element in A. So that becomes the range of the function. So domain of the function, codomain of the function, and range of the function. So that is the basic understanding of function. So same thing. So domain, it has 1, 2, 3, 4, 4 elements, and there is a mapping rule. Okay, this is a function. Some rule it is defined. So 1 has to be mapped to 6. So usually we will define a function as x maps to y. X maps to y. So some value in x, we are mapping it in the other element in the set. Okay. So that is the concept of domain, range, and codomain. Next, let us take an example. The function is what it is a relation which maps exactly one element from set A to set B, and then it also defines a rule. This is the rule how to map. So let us say this is my set A, this is called the domain, and we have set B, so this is called the codomain. So let us define set as 1, 2, 3, 4 elements. Okay, here say we have 1, 2, 4, okay, 8, 9, 16, something like this. Some elements are here in set B. This is codomain. Now you define a function f of x. That means there is a relation between A and B defined by f of x with the rule that f of x equal to x square. So what it means? So if I take this x value, I have to map this 1, x equal to 1. That means what, f of 1 equal to 1 square. So this is 1. So if I take this as x and this as the rule, and then this is the x square and this is the x, that is what, this is the input, this is the output. If I put 1, I have to map this to 1. If I put 2, I have to map this to 4, 3 to 9, 4 to 16. What is the range? Range is the subset of codomain. Which all elements are mapped in the codomain? 1 are mapped by A, 4, 9, 16. This is the range. This is the concept of function. So this is the rule and this is the relation. Okay. So before going ahead, let us understand the concept of open interval, closed interval, and half open. So when we write something like this in the brackets A comma B, this means open interval. Open interval means what? The end points are not included. End points are not included. For example, say that I have 1, 2, 3, 4. If I write 1 comma 4, okay, so I am only considering 2, 3, that's it. 1 and 4 end points are not included. That is, A is strictly less than x, x less than B. So A, B are not included, strictly less. Similarly, if I write like this square brackets, this is called closed interval. Closed interval means the end points are included, so less than or equal to. So in the same example, I take 4 elements 1, 2, 3, 4. This I take the interval, closed interval 1, 4, it's closed. So this point is included, this as well as this, both end points are also included. Now half open means A comma B. This side, so wherever you see this is closed, this is open, this is closed. So this value will not be included. This is half open example. That is, if I write like this, A is less than or equal to X less than B, because B is not included. So for this example, 1 comma 4, if I write like this, 1, 2, 3, 4. So 1 is included, 2 is included, 3 is included, but 4 is not included because it's the open, half open. Similarly, on the other side, this implies A is strictly less than X, less than or equal to B. So if I take this line, same interval 1 comma 4. So 1, 2, 3, 4. 4 is included because it's closed interval. This side included, but this side it is not included. That is the concept of intervals. Now, how to plot a graph of a function? Suppose that this visualization of the graph of a function is very important when you solve some complex problems. So let us say this function f of x equal to 3 minus x. So let us take the set. So it takes values 1, say 1, 2, 3. And then this set takes value 3 minus x is x. This is the output in the function. Function is 3 minus x. So let us for simplicity only take the range. So when x is 1, what is y value? 2, 3 minus x. When x is 2, this is 1. When 3, it is 0. Okay, this is the range. Now how to plot this? See, they are already told you it's a ordered pair. That means x comma y. So 1 comma 2 mapping. Then 2 comma 1, 3 comma 0. So in the graph, the x-axis is the input. Y-axis is your function. So in some textbook or in some exam, you may say y equal to f of x, they write. Or you write it as somewhere dy by dx. It is equal to df of x by dx. That means y also represents a function in the graph. That is y-axis. Y-axis represents the function. So input, if I give x as 1, okay, here x as 1, what should be y value? So x as 1, y is 2. So this is the point. Y is 2 here. X is 1 here. So like that you plot the points. Next, domain and range. So there is some concept called as R. You have seen this. Write something like this or like this. So it means real numbers, set of real numbers. That is minus infinity to infinity. Any numbers, it can be rational, irrational, any numbers in this interval. Okay, so minus 2.35 plus 2, integers also included. So that is, it represents the real numbers. So for example, 1 comma 5, when I say range, okay, for this example, the same f of x equal to x square. F of x equal to x square. What is domain? Domain means what all the x can take. X can take what? All in the entire range, right? Minus infinity to, that is plus infinity. Any value I can take. What about x square? The range, what all the values it can take. See, put any x value, you will always get a positive value because I'm squaring it. When if I put a negative value, it will be positive value only. So it is, how will you write? Range is not R because there are no negative values included. It can take 0. If I put 0 here, it can take 0. And then infinity. Okay, 0 is included. That is why it is this bracket. So that is the range. This is how you have to identify for a given function what is the range. That is very important when we solve many problems. Now, something called as piecewise defined function. Piecewise means function that we define as a rule. The rules can be multiple rules. In the previous example, f of x equal to x square. But here, for some interval, I should say 3x plus 2. That means from 2 to infinity. Okay, I will say this is 3x plus 1. So whenever the values are here, the domain values, if you get these values, you have to use this function. Else use this function, that is for less than 2. Okay, I hope you are getting. So what is this interval? So less than 2 to so minus infinity. It will go till minus infinity. So 1 to minus infinity. Or you can write minus infinity to 1 either way. Next. So for example, in this case, when I say f of 5, so x is equal to 5, right? 5 means what? I should use this function 3x plus 1. That is 16. 3x plus 1. When I say f of minus 1, I have to use this because less than 2. So this is equal to 1. Okay. Now there are different classes of function. Classes means based on their properties. You may already heard them. So linear, quadratic, polynomial, rational, exponential, logarithmic, trigonometric, absolute value. So these are the most widely used. There are many other function classes, but just try to understand their graphs because this is very important to understand how they look like. Okay. So definition is of the linear function. You write it as mx plus b, where b is the intercept, m is the slope of the line. Okay, for example, 2x plus 1, it is 2, m is 2, b is intercept is 1. If you observe the curve, what is the domain? The domain is what the x values can take any real numbers, right? I can give any real number. Range. So range means the output what I get. If I put any value here, I can get minus infinity to infinity, this line, for this line. So the range is also R for this. It doesn't mean that all linear function will have same. Okay, for this example, I'm saying this is how I have to identify for each given function. Next, quadratic function. It is of the form ax square plus bx plus c, where a, b, c are your constants. Okay, and a is not equal to 0. If a equal to 0, what will happen? It becomes straight line, right? So for this function, say x square minus 2x plus 1. So if you identify what is the domain, x can take any values minus infinity to plus infinity. Okay. Now, what is the range? See, this looks like a parabola. Okay, parabola. So, what is the range? See, if we put any x value, always you will get 0 or more than 0. Okay, greater than or equal to 0. F of x is always greater than or equal to 0. So that is a 5 given range 0 included into infinity. A polynomial function as the form. So next is the polynomial function. So we write it as, so with a n, the polynomial, for example, cubic function x cube. 3 is the highest order. X cube minus 3x square plus 2x. What is the domain of this? Domain x can take any real numbers. Range is, again, can take positive, negative or any values. So again, the range is also a real number. This is how this cubic function looks like. Okay. These functions, you not remember them, but at least you should have an idea. A quadratic function looks like this. A cubic function looks like this. Okay. Next, rational function. Rational function is the ratio of two polynomial functions. Okay. Two polynomial functions means the previously was seen, no? Okay, polynomial. So quadratic is also polynomial of order 2. That is what you can say. Now, if you observe here, So P of x is one polynomial, Q of x is another polynomial, where Q of x is not equal to 0, because if it is 0, then it becomes infinity. Let us take this example, f of x equal to x plus 1 divided by x minus 1. Okay. You may say that f of x equal to 1 only, because it is 1. So if I put 1 here, it is not defined. Okay, that's correct. So now, what is the domain of this? All real number except x equal to 1. By, see, if I put x equal to 1 in the domain, then I cannot define, I cannot map, because it becomes infinity. I cannot map x equal to 1 to infinity. So that's the range by its domain of all real numbers except 1. Other than 1, it is anything like that. So for example, minus infinity to infinity other than x equal to 1. X can take any values other than 1. What is the range? See, this concept again I will come when I explain the limits and continuity. Okay, that is, these are the basics for all those concepts. All real numbers except 1. So the range is all real numbers except y equal to 1. Okay. Why? So we will see in continuity why this is not possible. Okay. Can you get y equal to 1? Think about it. Okay, will we go to that point? You just keep thinking, is y equal to 1 possible with this function? Okay, next, exponential functions. So exponential is of the form a power x. Okay, a can be, for example, e power x, you have seen, no? E power minus x, whatever. So for example, this is how the graph looks like. Previously, this is how the ratio looks like. So this p by x by q by x. Two functions in the either direction. X minus 1 means this side, x plus 1 means that side. Domain of 2 power x. So it can take, x can take any real numbers. That's what it means. What is the range? Range is 0 to infinity. 0 to infinity. See, this is open. Why? You put any value here. Can you get 0? Can f of x be equal to 0? You put 0, it will be 2 power 0. That is 1. You put any negative number, any positive number, it will be greater than, other than 0. Okay, it will be greater than 0 only. 0 is not possible. Negative number is also not possible. So it is always ever increasing function, exponential function. That is what you learn in algorithms also. Next is logarithmic. Okay, logarithmic function is inverse of exponential function. So you take the logarithmic, you take the log for this function, both side, then you'll get a logarithmic function. So what is this? Log x to the base a, and a should be greater than 0. A cannot be equal to 1. Why? Log 1 is what? If I divide log x by log a, so log a equal to 1, what will happen? You already know it. F of x equal to log, what is the domain for this? So 0 to infinity. The x can take 0 to infinity. I cannot have negative values, I cannot get negative log values. This is a very fundamental concept. What is the range? It can produce all real numbers, the output, negative as well as positive. So the graph of log of something looks like this. So next are trigonometric functions, sine, cosine, tangent, and all. They are called periodic functions. Periodicity, see here in the graph, they are very periodic. So 0 to pi, this is the again pi to 2 pi. This is again from next interval, again you will get the same curve. So they are periodic in nature. For example, f of x equal to sin x. What is the domain? X can take any real number. What is the range? The sin value always fluctuate between -1 to +1, because 0 to 2 pi is what we give, right? Or -2 pi to pi. Okay. Next, see here can give any value, but what is, there are only 4 quadrants, right? There are only 4, first, second, third, fourth quadrant. The total is 360 degree only. Okay. So whatever you do, if you give a big number, 720 degree, that is again converted to these quadrants. Is negative or positive, you will get it. That's how you solve your trigonometry functions. Next, this is one of the important thing, mod x, that is also called absolute value function. In your integration differentiation also, you have to be very careful. What is the interval you have to check? F of x equal to minus x when x is less than 0. F of x equal to x when x is greater than or equal to 0. So mod x is a step function. We take minus x when x less than 0 plus x when x is greater than or equal to 0. If you observe the output here, so always f of x will be positive. The f of y, this y axis, to draw this graph, okay. So for x greater than or equal to 0, it is always positive. For x less than 0, it is negative, right? So for functions, how will you define it? For example, take this f of minus 5. F of minus 5 is equal to, we'll write it as mod of x. That is mod of minus 5 is equal to 5. Okay. F of 3 is 3. F of 0 is 0. So function of mod means it will become positive. That's what it means. So mod of x is greater than or equal to 0. Mod of x equal to 0 implies x equal to 0. So mod of AB equal to mod of A into mod of B. Similarly, mod of A divided by B equal to mod of A divided by mod of B, and where B is not equal to 0. Mod of A plus B is less than or equal to mod of A plus mod of B. Why? Okay. See, for example, if I take 2, A is 2, B is 3. So this will be mod means 2, B is minus 3, let us say 2 minus 3. This is mod of 2 and then plus mod of minus 3. So this will be minus 1, and this will be 2 plus 3, because mod of f of mod of x is x only. Okay. So this will be minus 1 and this will be 5. So they are not equal. So that is why they are written less than or equal to. This value will always be less than or equal to this. Minus 1 is less than or equal to 5. That's true. Okay. So thank you for watching. We will continue with few more important concepts and function in the next video.